Hey guys, welcome to video 2 in portfolio theory, and today we're going to be looking at the power of compounding and how asset management fees can significantly hurt those returns over the long run. We're also going to be working with our first for loop, which is some exciting news. So today we're going to be simulating a 40-year investment holding period where we're assuming a 5% rate of return annually, and we'll also be investing $10,000 into this portfolio annually. And then we'll be looking at 4 different scenarios where our portfolio is subject to fees of 0, 20 basis points, 1%, and 2% annually. So the first thing we need to do is code these assumptions and assign them variables. So we'll say R is equal to 0.05 for our rate of return. We'll say INV is equal to 10,000 for our annual investment. And then we'll say TT is equal to our holding period. And to do this, we're going to create in NumPy a range, which is essentially just creating a sequence. And we're going to say the sequence is from 1 to 41, and we're going to step by 1. And then finally, we just need to create an array of our fees. So we're going to say NP array is equal to parentheses, brackets, and then we'll just say 0.002 for 20 basis points, 0.01 for 1%, and then 0.02 for 2%. Next, we want to assign a return variable that's going to take into account the annual fees from our 4 different scenarios. So we're going to assign the variable RR is equal to 1 plus R, and then we're going to multiply that by 1 minus the fee, and then we'll subtract 1 from it. And if we return this variable, we should get an array with our returns, but now taking into account the fees. And you can see that it's been correctly uploaded. And the last thing we want to do before we calculate our annuity values is we want to form a matrix of zeros. So we'll assign the variable matrix, and we'll say that's equal to np.zeros. And the structure of this matrix, we're going to say has 40 rows and 4 columns. So if we execute this, we can just see our matrix of zeros. And that has been correctly uploaded. That will later fill in our annuity values from our 4 different scenarios. Before we put the annuity within the for loop, I think it's best to write out the annuity formula just to get some intuition behind where it's coming from. So before I write out the annuity formula, if we just Google an annuity formula online, this is what we find. So all we're doing is coding that in and then adding an adjustment where we can calculate the value at every sequence point within our array or every year within our investment period. So we're going to start by saying future value is equal to parentheses 1 plus R, and then we're going to multiply or take it to the investment period power, and then we're going to multiply that by our investment divided by our rate of return, or 0.05. And then we're going to multiply it then by our annuity formula, which is 1 minus 1 divided by parentheses 1 plus R to the TT power. And again, there's nothing special about this formula. It's a well-known formula on Google or online you can find. It's just the first term within this is an adjustment that allows us to calculate the annuity value at every point within our sequence or investment period. So now we need to put this annuity formula within our for loop, and then we can calculate the values of our investment holding for the 4 different scenarios. Okay, we're ready to create the for loop. So we're going to start by assigning the variable I in range 0 to 4. So it's going to be the I variable is going to be iterating from 0 to 4. And then within the body of the loop, we're going to say the matrix, our matrix of zeros, subsetting all rows, and the ith column. So within every iteration within this loop, the matrix ith column is going to be filled with our annuity values. And to insert our annuity values, we just need to copy the formula down. And the only adjustment we need to do is change the variable R to RR to account for the array of fees. And then we're going to be iterating that RR variable over the ith iteration. So it's first going to be the iteration with 0 fees, the iteration with 20 basis points, 1%, 2%. So we'll just change this quickly. And if we leave the loop by leaving the indent, we can return this matrix, and we'll just say let's round it out to 2 decimal points. And you can see that our annuity values have filled within the matrix of zeros. And the next step is to do a little bit of data visualization to determine how significant the 2% fee was to our portfolio that was subject to 0 fees. Okay, we'll start our data visualization with the plt.plot function. Just make sure you have matplotlib downloaded. And we'll put in our matrix, all rows in our 0 column. So this is going to be the portfolio with 0 fees. And then we're going to label this because we're going to add a legend later. And we're going to say the label is equal to no fee. And let's just adjust the line width. So we'll say LW is equal to 1. And if we execute this code, you can see that our first portfolio with 0% fees annually has been uploaded into our plot. So the next thing to do is just add our other 3 portfolios. So we can just copy these down and change the column number from 1 to 3. And I'll adjust the labels names, but for time purposes, I won't right now. And we can execute this code. And you can see that all 4 portfolios with 0% fees all the way down to 2% fees has been uploaded. So now we just need to add a title, X and Y labels, as well as a legend. And then we'll do a little bit more analysis on how much the 0% fee portfolio really saved you. I've gone ahead and finished this plot by adding titles, X and Y labels, a legend, and text within the actual plot. Most of this code's starting to get redundant, so if you have any questions, I would just download it within the portfolio theory section and re-execute it, and it should be pretty intuitive. But this is the end of this video on the power of compounding, and I hope you now have a better understanding and how much asset management fees can really erode the value of compounding over the long term. Thanks for stopping by.